Alright class, today we are starting Unit 11, Electrostatics. Everyone sit straight, focus, and imagine I'm standing right in front of the board explaining this. Electrostatics is a branch of physics where we study charges at rest. Remember, in current electricity, charges move through wires. But in electrostatics, charges don't move, they just stay fixed, yet they can still exert forces on each other. Example: have you ever rubbed a plastic pen on your hair and then seen it attract tiny pieces of paper? That's electrostatics. Why is this important? We need to understand how charges behave, because the same principle explains how sparks form, how photocopiers and laser printers work, and even how your body sometimes shocks you when you touch a metal door handle after walking on a carpet. The first big question: when two charges are apart from each other, how do they still feel a force? This is called action at a distance. The answer: every charge creates an electric field around it. If another charge comes into this field, it feels a force. So, charges interact not by touching, but through their fields. Key ideas in this chapter: 1. Coulomb's law explains the force between two charges, attraction or repulsion. 2. Electric field, a region around a charge where its effect can be felt. 3. Electric field lines, imaginary lines to represent the direction of force. 4. Gauss's law, a shortcut to calculate fields in symmetric situations. 5. Flux, how much field passes through a surface. 6. Electric potential, work done in moving a charge. 7. Capacitance, how capacitors store charge and energy. Real-life connection. At a petrol station, static electricity can cause serious danger. If your body carries static charge and you touch the fuel nozzle, a spark may occur. Gasoline vapors are highly flammable, fire can start. That's why it's advised to touch metal first to discharge static before fueling. So to summarize for today, electrostatics is equal to charges at rest. They interact through electric fields. This chapter will teach us how to calculate and visualize those forces, and how devices like capacitors use these principles.